Okay, so we're going to look at the 3.5 questions higher tier homework. This is on waves. 3.5 is part of the GCSE spec. So let's get started then. So we're first going to be looking at question 2. Starts on question 2 rather than 1. So don't worry that you're missing a page. So teacher demonstrates water waves in a ripple tank. Okay. Now, water waves, first thing I'm thinking, we've said before, they are transverse, okay? So we've got a transverse wave here. Now, diagram shows the waves at a particular frequency, and I've got this here, okay? And they've given us x, this distance, and what I've noticed is that, can you see that it goes from peak to peak, which means that I've got one wavelength here. I've just to put that on. Now, use the information in the diagram to calculate the distance x. Okay, so I know it's one wavelength, but I don't have any values on. So I'm going to start here, and I notice I've got two wavelengths, and that's in a distance of 3.2. So if I do 3.2 over 2, it's going to give me 1.6. Okay. I've then got a wave takes 5 seconds to travel 40 centimetres along the water in the ripple tank. Use the equations from page 2. Now, I haven't taken a picture of page 2 on this question paper because you'll have that with you. But the first thing, we've got time and we've got distance. So I'm going to use distance over time to find my speed, which is 8. Okay. Now, I've got my wavelength, haven't I, from up here saying it's 1.6, so I can now use V equals F lambda. So I've got velocity, frequency, and wavelength. So then I'm going to flip that, so I've got frequency equals wave speed over wavelength, so I've got 8 divided by 1.6, and it's going to give me 5 hertz. Okay, so two-step equation here, that's why it's 4 marks. And then got wavelengths travelling towards a plane barrier. Now, if you remember, this is like when we look at our waves from that bird's eye view. Okay, complete the diagram. So I'm showing that the wave is travelling towards my barrier, and because we're hitting head on, we're going to get reflection here, because it says reflect off. Now, the key points with these wave fronts is that they are the same spacing. It doesn't have to be completely identical, but they're the same spacing as they come off, because we're travelling still in the same medium. If we had gone into a more dense area, our wavelength would have decreased, so the gap between these wavefronts would have decreased also. But because we're staying in air, it's going to keep the same. So that's a key point there. When you're drawing your wavefronts, make sure the spacing is the same. Here we go. Now, my favourite rhyme, 7A. Complete the list. Red Martians invade Venus using X-ray guns. Red Martians invade Venus using X-ray guns. Now, just going to use my mnemonic here. Look, this is the easiest 2 marks in the world. I know Martians, the M stands for microwave, using U for ultraviolet. Okay? State one property that is common to all. Well, we've stated that they all travel at the speed of light, haven't we? So 3 times 10 to the 8. I've then got this big sort of body of text here, and just a bit of exam technique now. I'm not going to read that until I know what questions they're asking me. Okay, so we don't have to do these two because we haven't done that. It's a bit of triple. But now again, we've got this 4-step equation here. Okay, so the wavelength of light measuring the distance to the moon is 532 times 10 to the 9. And if we look over on our first body of text, it's got that there. We've got the 502 nanometers, which is down the bottom by here. Now, they've given me a frequency. Now, I've got to calculate the distance from Earth to the moon if it comes back 2.5626 seconds later. Now, what I want you to notice is that in the last 2-step equation, if you look, we did speed equals distance over time first, and then we did V equals F lambda. This 4 marker now, we're flipping it the other way around. So So I first want to find my speed, so I can use that speed equals distance over time. And we have found that the laser light, if we're using v equals f lambda, it equals 2.99 times 10 to the 8. And the reason why I've put it 2.99 is because we've been using decimal points. Okay? That was the answer it gave me into my calculator. And then I've got my speed then, haven't I? And I've got my time. So I can then rearrange speed equals distance over time. I'll pull my time over to this side to give me speed times time. I've got my distance is 2.99 times 2.5626, which is going to give me 7.66 times 10 to the 8. Now what I want you to notice by here is that time is for going to the moon and back. So I've got to divide him by 2 because I only want one journey. I only want to know distance to the moon. So it's going to give me 3.83 times 10 to the 8. Okay, now final question then. State why it should be separated by 2.57 rather than a continuous beam. Well, I want you to imagine here that we've got our Earth and we've got our moon, and I'm sending my laser up. If I send another laser before this first beam has reached Earth, they're going to interfere. They're going to crash into each other, and it's going to play with my measuring. So I don't want any crossover or interference. Now there's your homework for half term, second piece of homework. Good luck with it. Rewind it, pause it to help you out. Good luck.